In this video, we'll be evaluating logs when the logarithmic function has been applied to a radical. So in example A, I've got log base 2 equals root 8. So even though there's a radical in this, it's not going to change my procedure. I'm still going to set this equal to x. I'm going to rewrite it as an exponential. So I'm going to say 2 to the x equals root 8. But with exponentials, we know we don't really use radical signs or root signs. So what I'd like to do is change that square root to an exponent of 1/2. Now that I've done that, I want to look at the 2 and the 8 and rewrite 8 as a power of 2. So that will give me 2 to the x equals 2 cubed to the 1/2. So now I've got a power of a power on the right hand side, so I need to multiply the 3 and the 1/2. Doing that, I would get x, as the exponent here would have to equal this exponent, meaning x would have to be 3 over 2, which we could rewrite in this case as 1.5. We tend to like to keep our answers as fractions or exact, but since this does divide nicely to give us 1.5, this would also be an acceptable answer. Had this been something like 2 over 3, where we get a repeating decimal, we'd want to avoid that. In example B, we have log base 9 of the 5th root of 81. So we're going to take the same approach here, set this equal to x, and I'm going to say that 9 to the x equals the 5th root of 81. So I know that 81 is a power of 9. So I'm going to take this root sign, or the 5th root sign, and rewrite it as a fraction first. Remember that if we do that, the index of the radical becomes a denominator of the exponent, so it's 1 over 5. So I know that 81 would be 9 squared. So I'm going to say 9 to the x is 9 squared, and this is a 5th. So the same process as we did over here now. We said 3 times 1/2 was 3 over 2. In this case, we'll have 2 times 1/5 is 2 over 5. So x equals 2 over 5. Because the only way that this can be equal to this is if x is equal to the exponent we have here, which is the 2/5. And again, in this case, because that does divide nicely, we could say x is 0.4, but we usually prefer to keep them in fractional form.